All right, so here's a think, pair, share. And from this sample data, we're going to come up with an approximation of the theoretical mean and the theoretical standard deviation for the amount of time that a trout spends being fought on the end of a fisherman's line. So the following data contains the number of seconds between when a trout is hooked and either landed or lost. The sample mean is 7.47 and the sample standard deviation is 4.18. So if you put all these values into your calculator and you used it to calculate the mean, you would get 7.47 and the standard deviation you'd get a 4.18. Now remember, because we're dealing with a sample, this would be X bar and S. The histogram of the sample data appears to show a uniform distribution. So these histogram classes don't seem to be showing any kind of pattern other than maybe a horizontal one, a uniform one. And we're dealing with values of maybe a maximum of about 14.4 and a minimum of 0. So, a fish maybe went up to get a fly and instantly was not even hooked. And then 14.4 seconds, maybe it took that long to hook the trout and then to actually land it and take a picture of it and put it back. All right, so assume all the values between and including 0 and 15 are equally likely. So because we have a minimum of 0, we're going to have 0 here as our minimum value. And we've got 14.4. We could have used 14.4. It wouldn't have been wrong, but we're just going to make things simple and make it 15 up here. So it says state the values of A and B. So we're going to say A is our minimum value of our horizontal axis, which will be 0, and B is the maximum value of X, which is the maximum value on our horizontal axis. And that'll be 15. Okay, write the probability density function that models this sample. So the probability density function is f of x is equal to 1 over b minus a. And 1 over b minus a is going to be 1 over 15 minus 0, which will be 1 over 15. All right. How close is the theoretical, that should be population mean and standard deviation to the sample mean and sample standard deviation? So again, just like the previous example, we want to know how close are these two values and how close are these two values. So to calculate the theoretical population mean, it's going to be a plus b divided by 2. And a is 0, b is 15 divided by 2. And 15 divided by 2 is 7.5. And how does 7.5 compare to our sample mean, which was 7.47? So those two are pretty close. So that's good. Now let's calculate the theoretical population standard deviation. It's equal to the square root of b minus a squared all over 12. Let me make this just a little bit smaller so I got more room. Okay, b is 15 minus a, which is 0. That'll be squared divided by 12. So this will be the square root of 15 squared divided by 12. And that should come out to, see, I think that's going to come out to 4.33. All right, and comparing that to our sample standard deviation, which was 4.18. So what we can see here is that by taking our sample data and creating a histogram, and from that histogram, noting that the shape appears to be uniform, the sample data appears to show a uniform distribution, we could create a probability density function for this uniform distribution. And that lets us approximate what the theoretical population mean is and what the theoretical population standard deviation is. And so when we talk about the population, is this might have been, the trout caught by one person, on one section of a river. And when we talk about population, we're talking about trout caught by maybe this fisherman or fisher person across all rivers, right? The entire population of trout, something like that. Okay, so that ends this example. Let me know if you have any questions.